I'm trying to come up with a solution to this problem here. So, if anybody knows about these newer, you know, Ram Cummins engines, they know that these actuators are always going bad. So, I recently helped my nephew troubleshoot and replace one of these actuators, and it's just insane, right? So as you can see here, I mean, these things range anywhere from, new ones, 1500 bucks, whatever, and you can get rebuilt ones or remanufactured ones for, I don't know, like anywhere from 350 to again $1,000. And then City Diesel makes one that is a completely new one that has a billet case and all new electronics, and they put some code in there that helps kind of resolve some of these issues. But I don't think there's a perfect solution to this. So my goal here was to try and figure out how to fix these things, and I'm having some difficulty. So this video is really just if maybe somebody sees something in this video and is way smarter than myself and can maybe contribute to, I don't know, give me some next steps or some things to try, because I'm kind of out of ideas here. So basically what I've done so far is I have a board. I bought a used actuator which as far as I know did not work. It was bad, and I took it apart. There's actually a video of someone taking one of these apart, and it's a nasty thing to get these apart because of the glue that they use to basically seal this thing into the case. Um, I'll leave a link to that below so you can see how you basically have to take it apart. So the first thing is have to try and learn how to take one of these things apart without damaging them. And I ripped an inductor off and a resistor taking this apart. I've since replaced those parts. But looking at the PCB, it doesn't look overly complicated. So you have the main CPU here, which is an Atmel Mega 64M1 15MD. And then you have the motor controller over here, which is a ATA 6334C. I'll put the numbers down in the description below. My red annotation here didn't work too well, as you can see. And then this is a TLE 6250G. This is the CAN transceiver. Actually, if I scroll in there, yeah, you can see that better. So ATA 6834C, AT Mega 64M1 15MD, and then the TLE 6250G. So that's the front of the board. And it's, like I said, it's pretty straightforward. And then if we look at the back of the board here, let me pull that up. So here's the back of the board. And again, not too complicated here. Down here you can see this is one of the resistors I ripped off. I have since replaced that. It was a 100K resistor there, so I replaced that. You can see here the top of this inductor is glued into the case. So as you're trying to get it out, um, that's the weakest link, right? So it pulls it completely apart, which is not really a bad thing because then it doesn't rip the pads off the board, right? So I guess it's a good thing. But I replaced that with a 491 R0SC or ROSC. And you can see that this giant capacitor here was glued in as well. I mean, the benefit of having this out you can actually see where the glue pads are. So these holes actually go through the board. So I guess it gives it, better adhesion or whatever. But, you got glue here, here, around this hole here, down around here. It's basically all over this board. Um, so again, back to the components. So you have these power MOSFETs. This is a 4N0609, and then you have a position sensor, which is a 324 dBO. Okay, pretty simple. So I will put it under the microscope and kind of show you what I'm doing to try and figure this out. I tested the power MOSFETs. These all seem fine. What is it? So the drain and gate, yeah, I'm not sure, but it was 0.524 or something on all of these. So all of these seem good. Um, so that was my first check because watching videos on electronics repair and stuff, if you look at the Milwaukee videos people have done, it's usually these power MOSFETs. One of them goes bad, or more than one goes bad, and the motor stops turning. The issue with this one, so at the same time, I also bought a PCM out of I think it's a 2019 2500. So I've essentially hooked that up as a test harness. So the powers and grounds, and it also has the ignition on, and then obviously the CAN network. And so this thing has 4 wires going to it. You can see here, over here. So this has 4 wires going to it. These actually come out of the PCM, so they're not actually to power. This is to power, but it's a pin on the PCM. And then same thing with the ground. They call it a return. Basically, the return. So I've seen this thing, called different things, and it's special and all of that. Um, Basically, this just goes to ground, but they filter it. It's a signal return essentially. So it's filtered. It's not noisy, or it's not supposed to be noisy. So that's the special thing with the ground. And then you just have the CAN high and CAN low here. So it's 4 wires going in, very basic. So I've put this thing back together. I've hooked it up to the PCM, and when you apply power to it, it makes a noise, and I guess I can show that here. But then that's all it does. So when you apply power to it, I think that's just the motor or the MOSFET's energizing, is what I think that is. But again, I'm not sure. I'm looking for feedback here to try and figure out what's wrong with this board. So that happens. But normally, what happens is when I was helping my nephew, is if you have the actuator off the turbo and you connect the connector to it and then you turn the ignition on, what it does is it kind of sweeps. So I guess it's making sure it can travel to its limits. So it turns one way, then it turns the opposite way, and I guess it goes back to what it considers home. But this one does not do that. And then if I pull up the codes from the PCM, I get a U010C, which is a can't communicate. And there's also something else that happens on the PCM. There is actually a U001 code, which says there's something wrong with the CAN bus. If I unplug the actuator and I clear the codes and I bring them back up, that U001 is gone. So this actuator is doing something to the CAN network. So a couple of things that I did try was, or I did, measure, and I can actually show that under the microscope. So this is the CAN transceiver here. So if I apply power and ground to this, these two pins here are the can high and can low. And you can see they each go through a 60 ohm resistor. And then they go out to, they go through this. I think this is a EMF diode or something. Um, I guess reverse polarity network here or something. I'm not sure. Again, I need feedback on this. If anybody can help me out with this. So uh, this guy, I'll show you. You can measure it. Um, the ground is good. The power, I think, is pin 3, and I'll link all the data sheets in the comment in the description as well, so that if anyone's interested to take a look at this for me or help me with it. Um, that way, everything is easily accessible. So there's 5 volts going into this thing. There's kind of like an enable pin, and there's 5 volts on that as well. So my assumption is it's getting power, and I also measured the voltage to the ECU as well as the this motor controller here, and they both have power, so they should both be working. Um, the difference is, or the weird thing is when this thing has power, these can high and can low signals, they have voltage on them, and normally, from what I've seen on the internet, YouTube and stuff, they're pretty close to the same. Usually around 2.5 volts. But this one is a little bit different, and again, I'll show you once I put it under the microscope. But I think can low is like 1.9, and can high is like over 3 volts. I don't know if that's normal or not. Um, again, I don't know, but I'll try and show that under the microscope there. Um, but yeah, so this is just an overview of the board and the major components on it. And if anybody has any ideas here, I would greatly appreciate it, because the goal here is so people can fix these things, because this is ridiculous, right? I mean, granted, not everybody's going to rip these apart, but if there's somebody in your area that knows how to do it, maybe you take them a case of beer or whatever, and maybe they help you fix your actuator. I don't know. But there's got to be a better solution than, because even the remanufactured ones, they say they put all new parts in them, and, higher quality parts and blah, blah. I mean, you know, they're all ICs. What higher quality is there? I'm not exactly sure. You go to Mauser or wherever, and you buy replacement parts, right? So that's what I did. I got some of these power MOSFETs. I picked up, a couple of these guys, and I even picked up the CAN transceiver. Now you can't really change the ECU or MCU because it's got firmware on it. I haven't tried to connect to it yet to see if I could. I'm pretty sure they have it locked down, but maybe read the firmware off of there, and I don't know, because what I'd like to do is redesign this board and move all these components up here to where the coolant is, so that way they don't get as hot, because right here, this is where the gear goes through the case, so that way it turns the turbo, right? Well, this is all hot, and this MCU is down here in the heat, so is this motor controller. It would have been better to move all this stuff up to the end here and keep it at least a little bit away from the heat. But I don't know. I'm no PCB design expert or anything. So, but anyway, let's move over to the microscope, and I'll break out the multimeter and kind of show you what's happening here. And hopefully somebody can, have an idea or give me some guidance or something of what I'm doing wrong or what I should be looking at. All right. See you in a minute. Okay, so here's my basic setup. I apologize for bad lighting and everything. I have the board in a one of these little cheap board holders. Nothing is touching any components on the bottom. These three tangs, so that way nothing can short out or whatnot. So this is where I have my power and ground. So I have it connected to an external power source, which is about I think I have it set at 12.3 volts, if I remember correctly. So, um, what I'll do is I'll change the camera so you can see the voltmeter, so you can see what I'm doing and what the results are that I'm getting. So let me switch the camera. So this is the basic setup that I have, and let me switch the camera to point to the uh, voltmeter now, and I can show you what I've discovered so far. All right. Okay, so hopefully you can see that. Um, I don't know how YouTubers do this. It's a lot to try and get all this going. Anyway, um, so right now, as you can see, I have 12.32 volts. So if I go on the ground here, and you can see on the left side, I have 2.59, 2.59. And then on the other side of these guys, I have 1.943 and I have 3.24. And it looks like I have my leads reversed, so all the numbers are backwards, of course. So let's do that again. So I have 1.943 and I have 3.24. So let's see, which one is can low? So this is 3.24, 1.94. So can low is under 2 volts, can high is over 3 volts. So I don't know if that's normal or not. And this is kind of the difficulty here. So pin 3 is my 5 volt, and then I believe it's this guy here, pin 5, is also the 5 volts. And then this guy is ground because low is active, I believe. So I don't know. Besides the voltages, this seems to be working correctly. Um, and then you can see here the fuse. Sorry, wrong ground. What is that? Wait a minute. What? Okay, so the fuse is 12 volts. That's weird. Okay, so I guess that's normal. I don't know. Um, so yeah, that's what I'm dealing with there. And then if I come over here, move this. If I come over here, so you have VCC, which I believe is this via, and that's 5 volts. So this guy's getting 5 volts, and then VCC over here, which is this guy, he's also 5 volts. So this 5 volts going into the MCU. So, I mean, it looks like I have everything I need for this thing to work. Now, I'm sure there's a lot more to it, but yeah, I don't know where to go from here, honestly. Um, those voltages on the CAN bus seems very strange to me because I thought they were supposed to be 2.5 volts, but I don't know. So Okay, let me turn power off here and I can show you the tests that I've done to verify the power MOSFETs seem to be working correctly as well. So let me get that set up. All right, so now I have the multimeter in diode mode. So if I put the ground on the, I believe that's the drain, you can see there's nothing there and nothing there. Oh, sorry, not actually in diode mode. Now we're in diode mode. Okay. So as you can see, that's 0.522. And then if I come over here, it's open. So if I do that on each one, you can see 523. So all of these are like this. 524, 523. Switch this around. 523 and 523. So I think those power MOSFETs are fine. So yeah, I'm really not sure where to go here. I did take this off because this was giving, I'm not sure how to measure this correctly, but I originally thought that this had a problem. So you can see there, that's, 1.388. And then if I go over here, I get 0.832. But then if I do this, I get 704. So I thought that was a transistor, but I don't know what that is. And a transistor, I don't think these two pins should, you know, do anything. But yeah, I don't know. And then also if I do it the reverse, right, I still get, 131. So I'm not exactly sure on that measurement. So again, any help would be greatly appreciated. Um, I don't know what to try next. Uh, but the error is it's giving a CAN error and I don't know. So you can see I replaced that with a 100K resistor and then I replaced the inductor with that guy 491 ROSC. I did remove some of the the covering here, but that's all power pad or power pour, and then this trace goes underneath and comes out over here, and so that's not touched or anything. It's not shorting. So yeah, I don't know. I mean, maybe I damaged the board when I took it apart. I don't know. This is interesting. So this is a 100K resistor, but when I measure it, can you still see that? Hope so. Um, when I measure it, it's only 50K. And then the same thing happens on the backside. This guy here, so I thought that this was bad because it was only 50K, so I replaced it with 100K and it's still 50K. So somehow this one and the one on the other side is being divided somehow. I don't know if that's using it to, I don't know. I don't know, honestly. But yeah, I'm kind of out of ideas. I checked all of the resistors on the board and made sure that's how I found that these were only 50K. and I thought it was bad, but I took it off and measured it, and it was 100K. It's just in circuit, it was half its value. Same thing with the other one on the other side. But yeah, I checked all the resistors. I checked all the capacitors. The interesting thing with the capacitors is some of them don't give a value, and I'm assuming that's because it's in circuit. Um, if I do, if I just do a check for continuity, I don't get any continuity, which I don't know if I'm supposed to or not. But none of these have continuity, and I also attached to ground to see if both sides of the capacitors had ground, which they don't, only one side. So I don't think a capacitor is shorted out. So yeah, like I said, I'm at a loss. I don't know. Maybe something happened. Maybe this gets so hot and it goes bad. I don't know. But again, this is kind of like a cry for help. If anybody out there is smarter than me and could maybe give me some tips on what I could try or what I could measure, I would greatly appreciate it. So, but again, like I said, the goal is to be able to explain this, which I'm not doing a very good job to everyone, so that people can start troubleshooting and fixing these things, because it's just, I mean, the problem's not going away. I don't even know that the city diesel one's going to last forever. I mean, it still has components on it. It still gets super hot. So I don't know. Maybe they figured something out. I don't know. But yeah, thanks for watching. Um, I hope somebody can help me out. All right. Thanks a lot.